Hey everyone, we are going to start off with looking at our website before we kind of jump into the first lesson, which is the first derivative rule. Because we just want to highlight a couple things that we're going to kind of glance over and then kind of jump right into. And it's this idea of finding critical numbers. Uh, Critical numbers are where your function has a slope of zero and where your function is undefined. Otherwise, your function should either be increasing positive slopes or decreasing with negative slopes, or decreasing with negative slopes, increasing with positive slopes. So your function is either increasing, decreasing, has a zero slope, or the function doesn't exist at a point. So the zero slopes are critical numbers, and where the function doesn't exist, those are our critical numbers. So if we go to our lesson then, and if you've got example number one there for the first derivative rule kind of up on your screen, and if you draw a graph for this, you can see how I've got some points on here, and I've got tangent slopes that are positive, so my function is positive in this region. I've got tangent slopes that are negative, so I've got decreasing in this region, and I've got points that are, again, tangent slopes that are positive, so the function is increasing in this region. I have 2 points where I have slopes of zero. So for my question, I'm going to find two critical numbers. And if you kind of look at the scale, I got -1 is going to be a critical number and -3 is going to be a critical number. So I can see that with my graph. I just want to be able to, I guess, do the algebra, do the calculus to show that. So we want to know where are the critical numbers, and we find them by talking about where the slope is zero or where the slope is undefined. But again, you only get undefined slope if you have a rational function. In other words, we have some place where it's dividing by zero. So let's go to our question number one. And again, I've got the work kind of pre-done here, and I just want to talk about it. So we first of all need to understand we're talking about finding slopes. So we want to make sure we understand finding slopes is just, again, finding a derivative. I want to know the critical numbers, Cn, critical numbers, where my slope is zero and where my slope is undefined. No undefined in this question, it's a polynomial function. Derivative, right? So power rule, chain rule, all those things, whatever you have to do. This is a pretty easy one. Make it equal zero because you're finding the slope where it equals zero. That's the idea where the zero comes from. And you solve. And just like we saw in the graph, -3 and -1 are our two critical numbers. And just like we saw in our graph then, we knew that on the left side of -3, so from -infinity to -3, if I drew a tangent in there, all those tangents had positive slopes. So from -infinity to -3, I've got positive slopes. My function's increasing. On the graph, when I went from -3 to -1, I had negative slopes. My function was decreasing. And then when I went from -1 to infinity, I always drew positive tangent slopes. My function was increasing. So I know the answers. I just want to be able to figure out the math to justify it. So I like to use a table, and if you kind of go to your textbook and look at a table, it's going to kind of show that same idea of using a table. And my domain, I'm going to put 3 rows into my table to match the 3 regions from -infinity to -3, -3 to -1, -1 to infinity. Again, you can never get to -infinity, so it's round bracket. I don't want to include -3 in either one of my rows. I don't want to include -1 in either one of my rows, because at -3 and -1, the slope is zero. It's not a positive slope, it's not a negative slope. And it's important to understand that we want to know positive slopes and negative slopes in a region. How do you figure out what the slope is? You don't actually have to use factors. You could just use the derivative and then plug any number you want within this domain into your derivative, and it'll tell you whether you get a positive number or a negative number. So any number between -infinity and -3 into your derivative will give you a positive number. It means you have a positive slope. If you have a positive slope, it means your function's increasing. I like to break it apart into factors, and then I deal with the idea that a negative number times a negative number is a positive number, because it doesn't matter what number I pick in this domain. If I add 3 to it, it's going to be a negative number. Like, for example, -10 plus 3 is -7. Now, if I pick that same number and only add 1 to it, it's also going to be a negative number. 2 negative factors multiplied always give me a positive number. And then same thing from -3 to -1. Pick any number you want. Like if you put -2 or -2.5 or -1.5, if you put it in the function, it's going to give you a negative value right in your derivative. Or if you break it apart by factors, -1.5 or -2 plus 3, that's a positive number. But -1.5 or -2 or -2.5 plus 1 is going to be a negative number. So I get a positive times a negative, positive factor give me a negative slope, which means my function is decreasing. And the same thing happens then with -1 to infinity. Pick a number in that region, plug it into the original function, you see the original derivative, you see that it's going to be a positive number. Or if you pick a number that's larger than -1, such as 0, 0 plus 3, 0 plus 1, or 2 plus 3, 2 plus 1, right? You get two positive factors, so you know your function's increasing. So I like to use a table to help me organize my thoughts in terms of what's happening with my slope. So what's important here is that you actually have a slope column and you actually have the function column. You want to identify the slope as positive, meaning the function is increasing. The slope is negative, meaning the function is decreasing. The slope is positive, meaning the function is increasing. And then we want to talk again about whether you have maximums or minimums. And like we showed on the previous graph, and I've got it down here as well, when you go from an increasing function and also you're in a decreasing part, between a positive slope to a negative slope, you hit the maximum. And that's the first derivative rule. Or when you go from a slope that's negative to a slope that's positive, when you go from negative slope to positive slope, you hit a minimum. And we're just going to call these local maximums and minimums at this time, because at this point here at -3, and I didn't find what -3 is at, but judging by my scale, it's at 2. So at -3, 2. The height of 2 is a local maximum because the function goes way higher than that, but that's a local maximum. -1, you're calling a local minimum because, again, it's within this region of decrease to increase, because, again, you know that there is a negative infinity is going to be your absolute minimum. So that's our first example, trying to have our calculus justify what we already know from looking at the graph.